Testing one.
The American householder in his car uses 37% of all the total energy consumed in this great country of ours. And this is a tremendous amount, and we have to do something about it. What can we do to save energy in our homes? First and foremost, we need to change our habits, and I think this is probably the hardest thing of all. And it will be for me, and I'm sure it's going to be for you. I don't feel that we have to give up using any of our appliances. I think we can continue to use them, but we certainly have to learn to use them more wisely than we have. I'm going to pass out some booklets after this program, and these booklets are 104 ways that you can control your electricity bill. I hope everyone here tonight will take it home and read it and study it, and you may be surprised from the things that you'll learn from it. There are a numerous number of ways. My remarks here tonight will be touching on a few of the highlights that you can save energy in your home. Some you may not have heard of, and some of these I'm sure I'm repeating what the last speaker has told you. Well, first of all, heating, we know, is the largest user of energy in your home, and it certainly has to be the most important thing that you can do to conserve heating will be through insulation. Weather stripping, you certainly can't forget to weather your doors and your windows. And windows, I feel, is very vital. You should at least have a double window in your home. If you have a single now, that's the first thing that I would do is put a second pane on there. But even consider the third pane of glass. It's very important. I'm sure most of you people have forced air furnaces in your home, and you've always heard to clean your filters. Well, you should clean them, and you should clean them once a month without fail. There's another thing that seems to be overlooked with forced air furnaces, and that's the blower that's in the furnace. That little squirrel cage blower gets filled up with dirt. I doubt very much if two out of the entire group has ever had that blower cleaned out. But it can cut your air volume through your ducts and through your furnaces by a fourth of the volume of air that needs to go through. And something has been said about lowering your thermostat tonight. I like to see the 68-degree setting. And remember, for every degree that you go over 68 degrees, it takes 3% more fuel. Your thermostat location is very vital in anybody's home. And I think it's real wise to keep it out of your hallway. That's one of the worst places you can put it. Your living room happens to be one of the best places, and of course keep the TV away from it and keep any lamps away from it. It casts a heat onto this thermostat and it changes the setting. If you have a fireplace, for heaven's sakes, close the damper. One of the best things that you can do with a fireplace, if you love it, is buy a glass front and put on the front of that fireplace and stop that draft that goes up the furnace. Another thing that I think is very important is attic ventilation. You should vent your attics very well. You've got to keep that insulation wet. If you get that insulation wet from a lack of ventilation, because this humidity will go up through the ceiling, it'll take more heat than without insulation. You've got to keep it dry. Anybody that loves fresh air in their bedroom, and we do, close that bedroom door. You can open up that window, but don't allow that air to come down the stairwell or come down the hallway and cool that thermostat off and put a draft on it. Basements, if you're not living down there or have rumpus rooms, I don't see any reason why your basement has to ever be over 50 degrees. Well, some cooling tips. I'd like to just touch on a few of those. Of course, the recommended setting today is 78 degrees. Again, this 3% follows true with cooling. If you lower it 1 degree, you're going to add about 3% to your fuel bill. And there's no reason to have your cooling thermostat set any lower than 78 degrees. Naturally, you want to shut your windows and pull your drapes whenever the sun is shining on it. And your walls, outside walls, should be of light color. Again, you want to clean your furnace filter, keep that clean, or a room air conditioner filter, you must keep that clean too. Another thing that you want to watch, if you have room air conditioner or central air conditioning, is that coil that sits outside. This time of the year when the cotton ball seeds are flying around, you want to get out there and clean that off the coil. You'll make your air conditioner that much more efficient. And when you buy air conditioning, you want to look into the EER rating. You're hearing some of this now, and this is a very important rating. And you want an EER rating of between 8 and 10. And another thing I certainly would advise when you buy air conditioning, go to a qualified dealer so he may size the air conditioner. Don't overbuy an air conditioner for your home. When you buy one too large, you're wasting your money, and you're buying too big a machine than what you need. And I say the same thing for heating. Your qualified dealer is your key to this, that you are properly sized with your equipment. Well, some of the appliances we have in the home, what we can do about those? Well, refrigerators and freezers. Don't buy one any larger than you need. There isn't much sense. You've got so many cubic feet that you're going to have to cool, and it's just wise to buy one your size for your family. Again, you've got some coils in the back of of your refrigerators and your freezers, and you should take a vacuum cleaner and clean those off too when the lint gets on them. The door gaskets in your refrigerator should certainly be tight. This is what seals your cold air in. And a good way of checking that is taking a dollar bill and putting it in your door frame and shut your door. Now, if you can pull this dollar bill out real easy, you've got a relatively bad gasket in there that needs adjusting or probably replacing. If it pulls out real tight and it's real snug, then it's okay. One of the things you should do in your refrigerator is put a cover on your containers. So what happens, it releases vapors into the refrigerator, adds humidity to the refrigerator, and it's a tougher load to take care of. Frost-free refrigerators are wonderful. My wife wouldn't do without them, but they do take more power than a conventional refrigerator. Chest-type freezers probably cost a little bit less to run because the cold air holds down. Well, cooking, what can you do with cooking? Well, first thing you want to do is use flat-bottom pans. You want to adjust the burner to the size of the pan. If you're looking at that burner and you can see the outside ring, you've got that burner too large. You should choose a different one. And always keep the lids on the kettle too. You want to keep the heat inside. Those little reflectors that sit on the burners, right underneath the burner, those shiny reflectors, keep those clean too because it reflects heat back up to the pan. A good thing to use is a pressure cooker. They're much faster and it costs less to cook. Well, the ovens, what can you do with an oven? First of all, you want to adjust the racks before you turn the oven on. If you can bake, you should bake with a full load as much as you can. If you have to preheat your oven, never preheat it longer than 5 to 8 minutes. This seems to be sufficient. Your self-cleaning ovens, if you happen to have one of those, and it's in the summertime, why don't you clean it at night? Because those things do generate a tremendous amount of heat. And you should start your self-cleaning oven after you have been baking, while the oven is still somewhat warm. You should wipe up all minor spills in your oven so you do not have to use the self-cleaning oven as often as you have been in the past. Now, for the smaller baking jobs, there's no reason why you can't use a toaster, broiler, or even your frying pan. They take less electricity. And if I were you, I would consider an electronic oven. They're getting to be quite the rage today. They're much faster, and they use about 1/4 of the electricity, and they do a marvelous and a fine job. Some things were said about water heating tonight, and I think a very important thing is certainly locate your water heater as close to the source of where you want to use as you can. It shouldn't have to run all the way across the entire length of the basement. Now, if you have a leaky faucet, you want to remember 1 drip a second. In 1 year's time, you'll use 23,000 gallons of water. So that's what 1 drip a second will do, and you want to check that and keep those faucets tightly closed off. A shower will use about 1/2 the water that a tub will use. And there's certainly a savings. There is a little device now out that you can put in your shower head. It's an orifice that'll cut down your gallons per minute. No matter how wide open they turn that valve, it's only going to let out so much water. And that's about 2.5 gallons of water per minute. Your dishwasher, certainly, your dishwasher should only be used once a day, and preferably at night. And it should be full, because it's almost taking the same amount of energy to do a part load as a full load. So that's a good tip for you. And a wash machine, of course, is use more cold water soap. It works fine on a lot of fabrics today, and you should try it. And of course, when you wash clothes, you're better off washing with a full load than with a partial load. It almost again takes the same amount of energy to do it. Your dryers dry with a full load, always. But don't overload that dryer. And maybe you have to use the sunshine once in a while. We have a lot of that in South Dakota. You might as well take advantage of that too when you're drying. Dry outside when you can. But avoid over drying. Shut the dryer off early. Fold the clothes and lay them on top of the dryer to finish the drying. And it puts in less wrinkles into your clothes. I think a dryer should go into a dry basement. If it does, your dryer will dry faster. It isn't having to run the high humidity of the basement through its dryer, because that's where it's getting its air. Lighting, I guess the hardest thing in the world is having to turn off the switch. And you're probably no different than me. About half the lights in my house are on all the time, and I go around, shut the switches off, and they go around turning them back on again. But we may get that licked someday, but it's very hard to enforce. But be sure and keep your lighting fixtures very clean, because it has to reflect light. And after all, that's what you're buying. Use more task lighting. Put your light over where you're working. There's not much sense in lighting up the entire room to do some little task. Another thing, you want to use more fluorescent lighting. Fluorescent lights use about 1/4 of the power that incandescent lights use, and it will give you about 4 times more light. And fluorescent lighting is a beautiful light. You should use it more often. If you had a light fixture and you had 4 25-watt bulbs in it, you could put a 100-watt bulb in it and get 50% more light than you can with 4 25-watt bulbs. You should take inventory of your wattage of your lamps that you got at home and see where it's feasible for you to reduce. You should locate your hanging lamps in corners so you have reflection off the corners and you'll get more light from them. Some general rules: turn off your TV or radio when no one is watching or listening. Again, I think my TV comes on in the morning and it's on till about 10 at night, and half the time nobody's looking at it. So I come home and I turn the switch off. Well, I guess it's a matter of habit so that we can get in the best habit of doing that. But when you buy TV, you should buy solid state television and radio. It'll again use about 1/3 of the electricity that tube type do. There's a warm-up switch on these color TVs. And bear in mind, this electricity is on 24 hours a day. You may not know this. And if you check with your servicemen and ask them where you can shut this current off, part of these tubes are kept hot. And you can find out where you can do this. Now, he'll let you know. You can turn off this little switch, and it'll take longer for your color TV to warm up. But you're using less electricity. And I happen to have one in mine, and I did mine just recently after reading my notes, I guess. Another thing, too, don't use hot water with your waste disposal. Use cold water. There's no reason to use hot water. In fact, cold water will do a better job. But if you'll change your habits, you can save valuable resource and help control your energy costs. It's up to you and me, of course. Well, Northwestern Public Service Company, we started a new electric load management program a year ago. Wes Jarman, our division sales manager, is calling on all commercial customers, and Mary Small, our home service advisor, is calling on all residential customers. Their purpose is to help you and advise you ways to conserve electricity and gas energy. Watch for them. They are here to help you.
Thank you, George. That was very, very good. Very good. Give you some figures here to kind of back up what George was saying there. If you look at some of these very minor conservation measures in a national perspective, they can become very meaningful. You know, if all thermostats were lowered an average of just 6 degrees, we'd save the equivalent of 570,000 barrels of oil every day in the country. If our homes just had 6 inches of insulation on the average, we'd save 600,000 barrels of oil nationally. They're 42 gallons a barrel. And if we did something just as simple as caulking and weather stripping our houses, we'd save another 580,000 barrels of oil every day. And something that, sort of like what George was talking about, you wash your clothing in cold or warm water even, rather than hot water, you'd save 100,000 barrels of oil right there. And one other thing, if our cars average just 21 miles to the gallon, in other words, if we went back to the way they were in the 1950s, we could save 500,000 barrels of oil every day. We ought to have cars that make 40 or 50 or 60 miles to the gallon today, 1977. But even if we just got 21 miles to the gallon, that's what we would save. Next person on our program is Lloyd Turnwall. He's a superintendent of schools here in Huron, a division that supplied this building. And schools and other institutions that are major energy users, and we taxpayers pay for them, are very concerned about the energy thing because their bills are going up and their energy bills are very big every month. So Lloyd's going to tell us a little bit about what they're doing here in the Huron school system.
This is the non-expert part of the panel. Last November in the public school here, we became a little excited about the matter of energy conservation because it had become somewhat of a national issue. In fact, I can recall President Carter, one of his earlier telling statements was that, quote, all of us must learn to waste less energy. And I think that's very appropriate. And to that end, that is kind of the role the Huron School has tried to correct some of our operation. Back in November, we system-wide set the thermostats at 68 degrees. Well, in reference to 68-degree temperature setting, that sounds like that really isn't too cold or cool. But it really is kind of cool for a class sitting a half a day in a classroom with very little activity. So back in November, we sent letters home to all the parents. We were setting the thermostats at 68 degrees. We advised the parents to clothe their youngsters accordingly, have them wear warm clothes, wear boots or footwear that was warm, and if possible, keep a sweater at school. And I should tell you to start with that that's a little tough to do with kids. You know, this business of wearing overshoes to school, why, whoever heard of that, you know? They wouldn't want to be caught dead with overshoes on. Well, so you've got that problem. There are probably two chief reasons why we're concerned here in the school about energy conservation. One, of course, is cost, and the other one is how serious the supply might be. Now, we hear great things about the fear of a state or a national shortage. In fact, last winter at one time, in fact, the 19th of January to be exact, I know, but because it was my birthday, can't remember that, we were advised that we were to have our fuel oil supply cut by 50%, just like that. Well, as it turned out, that was somewhat of a scare, but nonetheless, it certainly is a sobering message to you. Now, I can remember, since I've been in Huron, that our utility bill used to be less than $10,000. And I can remember the night we had a board meeting and the bill came in at $10,000, and that the board just about fainted that it was costing that much monthly to heat and light the buildings. This winter in December of '76, our utility bill, fuel oil, electricity, and gas was $36,450. In January, the bill was $34,547. Now, that kind of makes you stop and think that it is a pretty costly part of our operation. For this current school year of 76 and 77, we budgeted $180,000 for utilities. And that, incidentally, was up about $35,000 or $40,000 from the previous year. And we think we're going to have overspent our budget this year. In 1977 and 78, our new school budget, we think we're probably going to increase that a like amount, somewhere between $35,000 and $40,000 for heat and light. Now, just information for you. All of our schools are supplied with natural gas and standby number 2 fuel oil, with one exception, a couple exceptions, excuse me. One is a senior high school. Senior high school is on uninterruptible natural gas. And the colony schools we operate are on propane. All the rest of them then are on natural gas with interruptible service, and the interruptible service is number 2 fuel oil. As an example, this very building right here, during the 74-75 school year, the utility cost for this one building right here was $7,422. A year later, in 75-76, the utility cost for this building was $9,502. Now, I don't have the complete figures as yet for this year, but through January it is $6,582. A year ago it is $9,502 for this single building. Senior high school, and I see the principal sitting out here, and I'd ask him to remember this. In 1974 and 75, our utility cost for the senior high school was $42,759. Last year, it was $52,817. Now, and I should remind all of you that, that's just not holding school. For example, I just came from there right now. There's 3 meetings going on in that building, and incidentally, I'm supposed to be at all of them. Nonetheless, the use of that building has greatly increased to the point that it's just used constantly, day and night. So it is understandable that those utility costs have greatly increased. Another factor on utilities, in 1974 and 75, we were on fuel oil for 63 days. 75, 76, we were on fuel oil 71 days. 76, 77, I think we have an approximately 75 days, and I'd hedge a little bit. I think this is correct, and I'm assuming we are through with that, hopefully, for the year. And I'm sure the supply of natural gas obviously enters into that figure. On the fuel oil consumption, 2 years ago we paid 31 6/10 cents a gallon for number 2 fuel oil. Last year we paid 38.3. This year so far we've averaged 39.3. You can see all of these figures are why those costs have just absolutely skyrocketed. Well, so anyway, when we got the big scare back in January of our fuel oil shortage, We then formed an energy committee in the school system. We had teachers on the committee, we had administrators, we had gas and oil suppliers on there, and came up with some thoughts. Now, understand, we're really grasping for some help. You see, we really don't have the expertise of how to properly conserve energy, and we think that we're going to make some marked improvements in our consumption. There are several things needed. For example, we're going to need some public understanding of reducing the temperature setting in the school. Back in January when we got that scare, we dropped the thermostat setting to 64 degrees. But I'm telling you, the old telephone got a little hot for a while. And it wasn't very popular. Teaching staff, they were a little snarly about that. That's understandable. It's pretty gall darn cold, 64 degrees, without a lot of movement in the room. Well, it's very possible that we're going to have to go back to the days of when I was a kid, and some of you out there, of the long johns. That's entirely possible. I kind of thought I'd outgrown those, but maybe not. And of course, one of the questions was asked frequently of me when you get a nasty phone call about how cold it was and little Johnny's going to get cold, was what is everyone else doing? Now, there's such a thing as saving money on energy costs, but if we're going to be the only one in the city of any large size that is trying to conserve energy, then our case loses considerable merit. In other words, is everyone else concerned about saving energy supply? Not for cost reasons, but to make sure we don't run out. And that's not only true here in Huron, but are those kind of measures going to be taken elsewhere? Just as an example, some of the things that we've are trying to do. For example, I think Monday night, I think our Board of Education is going to approve bids for new windows for the junior high complex. Terribly costly thing. It's going to be about $75,000. But the experts tell us that we're going to pay for those in about 8 years in energy savings. And I'm here to tell you the windows in that building are really, really bad. Quite a breeze comes through there. We've did a little work on the senior high school, the rooftop heating ventilating units. Now, at one time, when they were installed, the ventilation cycle was approximately 12 minutes of every hour. It'd bring in cold air. Well, you know, if it's 20 degrees out and you're bringing in cold air for 12 minutes, that has quite a energy concern. Reducing that. We're checking the windows and looking for excessive leaks. Close the shades at night and weekends. Smaller bulbs in the hallways, and in fact eliminating some of the lights completely. And a number of other miscellaneous things. Well, then we're also making a study of our energy use. For example, at the end of this year now, we'll have a study showing every building in the school system what it costs us for electricity, for natural gas, for fuel oil, and so forth. And we intend to maintain this. And as you would logically think, if some of the buildings show something exorbitant, well, it's going to kind of flash a red light, and we're going to know that there's a lot of leakage somewhere in that building. and that we'll be able to do something about it. And so basically that's where we are at the moment. Thank you.
Thank you, Lloyd. Certainly fortunate here in Huron to have a school administration that is so concerned about energy conservation. I think some other school systems around the state really haven't begun to deal with the problem yet. One interesting thing that's happening in the school area is that the new high school at Spearfish, I don't know if they started construction on that yet or not, but I believe they are this year. They're going to utilize solar energy in that, which is something that really wasn't available at the time we built the school here in Huron, but it's kind of an interesting thing that's on the forefront. Next, we've got two people who are very familiar, among other things, with insulation and what to look for when you're shopping around for that. The first person is John Feldeman from South Dakota State University in Brookings. And John and then Jim Valeer from State Farmers Home Administration are going to talk to us just briefly about that. Turn over to you, John.
Yep.
You've heard a number of tips here so far tonight about how to conserve energy. And a lot of these don't really involve any great investment except perhaps some of your time, changing your habits, that sort of thing. When you start talking about insulating your home, however, you're now talking about quite a monetary investment. Now you're probably a little more concerned about just how much good you're going to get out of it before you lay out the money. So I'd like to say just a little bit about how you might calculate the heat load in your house. Now, to do a detailed analysis is quite a task. There are some attempts to sort of simplify this. Here is one pamphlet which has a sort of a do-it-yourself heat analysis in it, put out by the Department of Commerce. And just on a quick glance, I noticed that this one, put out by the state, also has a similar thing. Now, I'd just like to point out a few terms here and show how a heat analysis is done. First of all, when you do a detailed heat analysis, hope everybody can see this reasonably well, you kind of break the heat loss up into different categories. First of all, you want to consider the heat loss through the ceiling, through the side walls of your house, through windows, doors, and then this thing called infiltration, which you've heard about already tonight. And this is one that's kind of hard to get a hold of. This is the air that comes in through any cracks around the windows, opening, closing outside doors, this sort of thing. There are a couple of different ways to attack this problem to get an estimate of how much heat you might lose here. One of them is to look at the number of air changes that you have in a given period of time, say an hour. This may vary, say, from anywhere from a half up to 2, perhaps. Give you an idea of what you have here. If you had an interior room without any windows or exterior doors, you might figure something like a half an air change per hour. Okay, this means you have to reheat half the amount of air in that room up to the comfort level every hour. Now, if you have a, say, something like a hall, which has perhaps an exterior door, you might get up to 2 air changes per hour. Perhaps through weather stripping and so on, something to shoot for might be something like 3/4 of an air change per hour. Okay, when you're looking at the ceiling and the side walls, you're looking at various types of insulating materials that you might use. When you're evaluating an insulating material, you want to look at its thermal conductivity or its R factor. Okay, these are related in the fashion I've indicated here. The R factor, or the resistance to heat flow, if you will, is the reciprocal of the thermal conductivity. So to minimize heat flow, you want a large resistance, a large R, or a low thermal conductivity. The R values may be given either per inch of thickness or as a total value, say for a full wall or for a given thickness. Okay, here are some of the types of insulations that you might use. The polyurethane has an R factor of around, anywhere from 5 on up to possibly 6. Still air itself is a good insulator with an R factor of 5.8. Then we get down to the polystyrene, fiberglass, which is fairly common, between 3 and 4 for an R factor. Cellulose, the chopped paper or wood fiber that's used as a blown-in insulation, about 3.7. Okay, here's one I stuck in that's one a little bit out of the past, hair felt or sometimes jute included with this. We have an older house, probably something like 40 years old, and it did have this type of insulation in it. The R factor is not all that bad, 3.4. The trouble is, in a 3.5-inch gap in the wall, usually you only had about 3/4 of an inch of this stuff, so it didn't fill up the full gap. Okay, the expanded vermiculite, about 2.31. Then I just added a couple other building materials here just for comparison purposes. Wood, an R factor of something like 1.25. Now you'll contrast this with the cellulose, which is in some cases just plain chopped wood. All you've really done here is chop up the wood, fluff it up a little bit, entrap some air, keep it still, and now you're using mostly still air as your insulate. Okay, some of your masonry construction materials, brick and concrete, so you have a relatively low R factor. So they don't do much for you in stopping the heat loss. Okay, the range in prices here is also fairly wide, so when you're purchasing insulation, one of the things you want to do is look at your house, see how much insulation you want to put in to save so much heat loss. So that way you can evaluate how much you're getting out of your each dollar expended. And I think Jim will speak a little more to this in a bit later. Okay, as an example, let's look at an outside wall. Here I've listed one for a common frame construction. Okay, the total R factor over here will be the sum of the R factors for each part of the wall. Okay, even though some of these parts don't help very much, say if you had a brick veneer, it wouldn't do all that much for you as far as stopping heat loss, but it all helps a little. Okay, you have a surface resistance on the outside just due to the air boundary layer. Not too large. This one happens to be for a 15-mile-per-hour wind. If it was a still day, of course, that would be a little larger. The wood siding helps some. Here is a sheeting of some type, an asphalt I've put in as an example here. And now here is the airspace. Okay, this is with 2x4 studding. So this is 3.5, 3/4 inches of air. Well, you notice the R factor is a far cry from the one I had listed for still air. Okay, the difference is here the air is moving. Why? Because you have a heat loss from the inside of the room, heating the air on the inside. This becomes less dense, more buoyant, tends to rise. So you have actually convection current in your wall, which is transferring the energy from the inside to the outside. If you can somehow trap that air, which is what you do with most insulations, you can increase the resistance. Okay, your wallboard does help you somewhat, and you also have some resistance just due to the air boundary layer on the inside. Here I've used still air, giving you more resistance than you had if you have a wind on the outside. Okay, so for the uninsulated wall, here you have a total R, total resistance, of about 4.4. Now let's look at what happens over here if I insulate that. And I've just taken a fiberglass, 3.5-inch insulation, which is commonly quoted as an R of 11. So I subtract out the 0.97, put in the 11, and this gives me a total resistance then of about 14. Okay, the ceiling, you do somewhat in quite similar fashion. Let's go on and look at something a little different here. Windows. Okay, here I've listed the total resistance again for just a single pane of glass. Okay, only 0.88. So you're going to spend a lot of money, insulate your sidewalls, get the resistance factor way up to 14, and perhaps just have single pane glass, which, if you have a large window area, is going to be the majority of your heat loss then. By using a double insulating glass, you can raise this, triple, even more. Here is just for a common storm window application, approximately the same as a double insulating glass, but just a little bit of difference. Doors, you can have a fair range here too. For just a 1-inch door, total resistance of about 1.5. If you go to a thicker door, up to 2 inches, put on a storm door. A wooden one is better than a metal one. You can perhaps raise that up to approximately 4. Okay, the amount of window area you have, window and door area, of course, indicates how important it is that you pay specific attention to these. If you have large window area, of course, you're going to lose more energy through the windows than through the walls. So it's much more important then that you perhaps go to triple glazing. Okay. So those are the resistance factor, how it's defined, and the typical resistance factor for some common material. Now, I think Jim will go on from here and talk about a few other things.
Well, I just show you real briefly proposed standards we've got in the Farm Home Administration for insulation. And I wanted to show you this first. We use Hudson and property standards, and they've sort of arbitrarily assigned insulation requirements to various parts of the country based on the number of heating degree days.